good afternoon, good evening, based on the time zone you have joined us today. My name is Victor Monga. I'm serving as board member of Virtually Testing. We have been talking about Zeek and Pro for a while. This is our second session of Zeek series, and we're going to continue working on this towards making it advanced Zeek workshops and hands-on exercises. So today's our simple agenda is that we're going to talk about Zeek install and config. A quick about us, Virtually Testing is a 501c nonprofit. What that means is all the donations paid to Virtually Testing is tax exempt. About me, I'm still a security learner, so I'm here to learn from Fatima and all of you guys. That is all about me. I'm pretty active on LinkedIn and Twitter. Please go ahead if you want to just look me up on LinkedIn. You'll find me, and it's the same picture, so you'll recognize me. With that, I'm going to hand it off to Fatima. Once again, Fatima is a great speaker. She knows a lot about Zeek, way more than me, so I'll let her speak to it. Fatima.
Hi, everyone. Good afternoon, good morning, good evening. My name is Fatima. I'm a security engineer at Berkeley Lab, and I primarily work on intrusion detection side and defense side of security. Know a little bit about offense, but my primary responsibility is building up defensive tools, like including SIEM, IDS solutions for the organizations and whatnot. Together with that, I have been active learner in the science community as well. So I have taken a couple of their courses and they were really good. So, and they kind of like helped me to do my job efficiently. So yeah, that's pretty brief introduction. Before joining Berkeley Lab, I used to work at University of Delaware. I was security engineer there. And with the similar responsibilities, I was the primary security architect for the SIEM solution that got deployed at University of Delaware. And then my main job was to look after our Zeek cluster and Suricata cluster and fine tune the alerts and find the detection, find the intrusions and do incident response. So that was a quick introduction about me. So for today, we are going to talk about Zeek. Zeek used to be known as Bro. If you guys are following along the older versions of Zeek, it used to be called Bro. They did the renaming recently, like 2 years ago, I think in 2018, they did the renaming, and now the project is called Zeek. So a lot of people are not still familiar with name Zeek. That's why I have put AKA Bro, so that if you know Bro, then it's pretty much the same thing, only the name has been changed. Zeek is a passive network security monitoring system. I used to call Zeek an IDS, intrusion detection system, and then I realized that there is a very good difference between an intrusion detection system or an IDS or an NSM. So I started calling Zeek an NSM, and because that's where it belongs as far as the functionality goes. So it doesn't detect anything automatically in your network. It's just a tool that passively sits in your network, passively looks for the traffic, grasps the traffic, and produces the log files for you. And those log files are very efficient, like they're flat ASCII files. And for each protocol it sees on the network traffic, it produces the corresponding log file. So it's super easy for you to do analysis and investigations. So for example, if I only want to see what my HTTP traffic looked like during that time period on my network, I can just absolutely grab the http.log file and go over that file instead of putting up a PCAP in Wireshark and filtering out the HTTP traffic there. So it's pretty nice. That's the key functionality of Zeek that I like about it, that it just generates the very efficient high fidelity log files on the disk right away from sniffing the traffic from wire and then producing the ASCII log files. The log files are pretty customizable. Like you can produce your own file if you are more advanced Zeek user, and if you want to extract out more features out of your network traffic, you can absolutely do so using the scripting framework that Zeek provides to you. And you can create your own log files as well. So for the basic log files that Zeek automatically produces out of the box, there are more than 50, like 2 or 3 dozen log files, because it has more than 50 protocol parsers. So every time it sees a corresponding protocol on your network, it produces a log file corresponding to that protocol. So those log files are pretty customizable. You can pull those log files. As I said before, they're TSV, they're tab separated format. So you can pull them in your SIEM solution if you have, or you can just directly If you're not using a SIEM solution, you can just directly go to the log directory of the Zeek and then pull down the logs or grep through it and whatnot, like a whole bunch of command line kung fu you can do on those flat files. So that's pretty impressive. Okay, so prevention is idle, but detection is the must. So I had a quick story here. So I was attending one of the seminars, and one of the, he was a very famous, he was the guest speaker, and he did a lot of, he was a consultant. At the same time, he owns his own security company for which they provide pen testing. So he was talking about how important it is to do detection first and then prevention. And he was having a hard time to explain that to one of the government agencies for which he was investigating a case. So they invited him over to the building, and then he went there, and then there were a lot of security checks when he went to the building, of course, because it was a government premises. So the way so throughout his way through the hallway, he saw a lot of cameras. And then when he went exactly to the executive to talk to him about why he was there, he just asked a very basic question that, okay, I see all those checks and security checkpoints that you have in the building, which is good, I really appreciate it, but then why do you have cameras? Like, you already have so many checks in place where you allow people and don't allow people based on, you know, different checks. Then why do you have cameras? So the executive was like, you know, if somebody just sneaks in, we at least have something to go back in time and check on, you know, what was going on at that time. And he exactly, he gave the analogy that this is it. This is, you already answered the question you were asking me, that what is the use of detection? This is the answer, that you have cameras because you trust your security, like you trust your prevention, but there might be cases where it would be nice to have a detection in place, right? So that was a small story behind prevention is idle, but you have to have detection in place. If you don't know what happened on your network, it would be really hard for you to portray a story of just by going to the log files. So coming back to the Zeek lab topology. So the VMs that we have provided to you, this picture is a little complicated, so I'll just explain it to you. So the cloud thing is internet, and the big brown box, brown box is our host machine, right? So this is our host machine, which is your host, whether it can be a PC, whether it can be a laptop. We all have interfaces, right, on our system, and then we have a Wi-Fi interface. So it doesn't matter whether you're connected to the Ethernet or the Wi-Fi. If you are connected to the Wi-Fi, you will be connecting to the access point, which will give you an IP address, and that access point is somehow wired connected to the internet, to your switches and routers and whatnot, from where it is providing you the DHCP IP address. This IF in green is the Ethernet connection. So again, the same path. So this one and this one, based on if you're directly connected, you will get an Ethernet IP, and if you are connected via Wi-Fi, you will get an access point IP that access point is providing to you, the range that access point is assigned to provide you, right? So this is the basic internet connectivity. Like the websites reside here. So this is like the whole big, this is like the whole big internet. So this is your primary connection to the internet, and this brown machine is your host machine. Now inside your host machine, when we say that we have VMware or VMware Fusion or workstation running, what exactly internally it looks like is, this is your VM inside it, like this green box, right? And the VM already have interfaces, right? When we put up the network interfaces on VM, I have crossed it out because this is the bridge connection, and there was an interface here, but I just crossed it out because we would not be using the bridge connection. So we only have one interface on our VM. That is the interface from which the Zeek NSM would be sniffing the traffic. So this interface is directly connected to your NAT box, which is the functionality provided in each and every host system. And this pipe here is the NATed pipe. So if you go on your local host system and open up a terminal or a SIGWIN and do an IF config or IP address, you will get an interface with a local IP address. So this is your local host machine IP address, and it is always .1. Doesn't matter what the 3 octets are, but it is the .1 is always your host machine. And after the .1, other ranges will be provided to your all the NATed VM machines that you are running on the box. So this is our box. We are NATed through it. So this is the range of our NAT address. It will depend. So this is from Windows. If it's Mac, it will be 172 dot something. So your interface would be getting one of the NATed IP address, and through this NAT we will be connecting to the internet. So your VM machine that we have provided should be able to connect to the internet via this NAT box. So the path would look like this and go over the internet. So this was the very basic diagram explanation. And you have your own browsers on your host, like your Chrome or whatever, Mozilla, and whenever you type in an IP address, whenever you type in a website, it goes through this path, right? Like it will go to your interface and directly to the internet, and your interface IP will be the actual routable IP. So not to go into the detail, but yeah, just wanted to make sure that you understand the concept, that how the VM machines get a NATed IP address and how you can directly able to communicate to your VM from your box, from your host box, because it also have an internal interface on the same NAT octet, net subnet, so NATed subnet. So that was the quick. So this is the machine we have provided that you have to unzip and install and open it up on either VMware Workstation or VMware Fusion. And this is where we will be installing Zeek. What's in today's lab? Virtual machine 1. If you have already downloaded the machine before this class, that would be best, because these machines are a little heavy. I think they're almost 5 to 7 gigs. So if you're installing it right now, it might take an hour or so to install. So you might not be able to follow through the lab, but they are super easy. Like we have the video as well recorded, so you can go back and see all the steps that we are doing. Shouldn't be a problem. But if you already have installed, so you should have 2 machines. One is the VT student machine, and then one is VT student Zeek 3.0. If you are having trouble in any point in time to install Zeek from scratch, you can absolutely spin up this machine, which has already Zeek 3.0 installed in it. So that's why we have 2 machines. So I will be working with the virtual machine 1 here, and I will be showing you the steps of how to do a Zeek install from the pre-binary packages. Pre-binary downloads, not the source installation. And then basic installation of Zeek on Ubuntu, it would just take a couple of minutes. Then configuration, what is the basic minimum configuration required to spin up Zeek and start it on the machine. And then we will be running Zeek for a few minutes and see if it is generating any kind of log files for us to investigate. Zeek installation, let's get started. If you have the machine, then go ahead and open up the first one, this one, because it doesn't have Zeek installed. So you can follow through the steps. So this machine, the VT student, if you have already downloaded it, it's a zip file. So you have to unzip it, which would just take a couple of seconds. Somebody just chatted. Okay, yeah, please let us know if you need any assistance. So yeah, go ahead, and if you have the zip machine VT student, go ahead and unzip it. Unzip the VT student.zip file. Here's the link. Open the VM in either VMware Workstation or the Fusion. I will be using Fusion. So if you are on the Windows machine or Windows box, you can absolutely go ahead and use VMware Workstation. Start the VM. The login is VT student account, and the password is caps VT small VT 2020 and exclamation mark. And then we will be checking the connectivity of the internet. So let me come out of the slideshow and go here. So I have it. I can show you where it is as well. It's on my desktop. So this is the VT student zip that I was talking about. It's almost 4 gigs. If you unzip it, you will get a VMware bundle like that. And then if you just right click it and say open with VMware Fusion, it is just going to open up here. So I'm going to just resume this virtual machine. And let me know if you guys have any trouble watching the screen. Okay, I can zoom in. Network is unreachable. Okay. So
This is perfect. These are the things that everybody would have to go through as well at home. So this is perfect. Yeah, you may want to go to settings and disable, enable these, Nick.
wait. It is not getting the IP address. So
And gang online right now, are you guys getting along as well, or okay, seems like everybody is on this step. That's good. All right. Okay, some of you are watching the demo. That's good. All right, good.
okay.
Seems like it.
Yeah. Let's see if we have. Okay. So finally, let's resolve.config. So resolve.conf is the default file that your networking service, while networking service boots up, what networking service does is it gives your machine an IP and it sets all the networking defaults for your system. So the etc resolve, this file actually consists of your name server settings and your settings for your local um, resolvers that your machine should be able to connect to. So since you see that my name server resolver is non-routable, so anytime whenever I would do ping google.com, google.com has to be resolved. So your system has to contact to a DNS server to resolve that name. So my name server here, is the internal loopback IP address, right? So it will never be able to resolve that. It will never be able to resolve that google.com for me. So that's why my ping to google.com would never work. But if I give directly IP address, which is 8.8.8.8 to ping, it is automatically going to work, because in that case, it is not going to contact the DNS server. So you can see here that it mentions your DNS server that your system should automatically contact and reach out. So that's why I was commenting out the name server with internal loopback and giving it a Google's name server IP address, which was 8.8.8.8. So I was telling my system that to not use my internal loopback for as a name server, use 8.8.8.8, which is my DNS server, which is Google's DNS server, to resolve the name. So that was kind of like, so when I was not able to connect to google.com, I just thought that I would just edit my internal networking service settings and see if it works. So if that answers the question. Okay, so going ahead, now we can come back to our slides demo. So it's super simple, super easy. You have to become root, which I am. I like to install things as a root, because then you don't, you can, the things that are used, the things that should get installed in default locations would not have permission issues. So that's why I use sudo. That's why I use root. And you just have to install the dependencies for Zeek. It doesn't have paste. Oh, yeah. So I'm just installing the dependencies right now for Zeek. So let's, I'll get to the, sure.
And as Fatima is going through this, she also had recorded all of this ahead of the time as well, and that was the link we'll be posting in the chat right now.
And funny part is, even that time I had some issues, so the troubleshooting part would be recorded as well, because it was recording. I couldn't like shut it down and say, no, I'm going to, come with a clean machine. So it should also have some troubleshooting as well.
That's good.
So just to explain, don't do this. Just to explain what this did, apt-get is the repository install command where Ubuntu uses to install the packages that are by default available in Ubuntu repository. If you're on CentOS, you can use yum command. CMake is the this basically, these commands, not commands, these packages are used to compile the source from the build. GCC is the C++ compiler, and G++, these are all your code compilers. So if you have, what version of CentOS? Zeek is compatible. So Zeek 3.0 is compatible up till CentOS 7, and they also have released it for CentOS 8. So CentOS 8 is very latest, but if you have CentOS up till 7, it should be fine. We are using Ubuntu, but similar commands you run on a CentOS box to install Zeek. It's pretty much the same. So these are different packages that are dependent, that Zeek depends on to get installed and compiled. We will be installing from pre-binary version, like pre-binary packages. So we would not be doing compilation from source. If you're compiling it from source, it requires a whole lot of other packages as well. So these are the bare minimum packages that Zeek binary depends on when it is running. So SSL, Python, Swing, glibc, and yeah, this clear was my command that I ran accidentally. So anyways, after installing dependency, we have to get the correct repository and add it to the sources list for Ubuntu repo so that it can find Zeek. So we are getting a Debian repository link for Zeek, so that next time we do apt-get install Zeek, it should find the Zeek package in the default Ubuntu repository. So let's see if that command works. It looks like it works. So what we are doing is we are pulling down the Debian. We are echoing this Debian command in the etc apt sources.list.d / directory. So that this is the default directory where the apt-get command looks for packages in the repositories. So that's what we are doing right now. We are adding this repository, which is OpenSUSE for Zeek, so that next time we do an apt-get install or apt-get update, this repository gets added to one of the repositories to search for. Now we are going to get the release key for the same repository to make sure that it's authentic. Okay. We're going to add that release key in the apt-get repo so that it doesn't yell about the package in the repository is not trusted. And now we will just do an apt-get update. Okay, so one thing to note about the apt-get update that I did right now is now it finds the repository that we just added. This is the repository that we just added, right? So how sudo apt-get update is finding it is because we added it to the sources list for the apt-get. So the commands that we ran here to add it and get the release key and add the release key, these are the commands that is helping sudo apt-get update to find the actual repository from which it can pull down Zeek when we will do Zeek install. So this is the in release package, and all the packages related to Zeek will be in this repository, which is pretty much the same. These two URLs are same. So that's why we did these steps, and that's why we were doing apt-get update again to verify that it is finding the correct repository. So the next time we do an apt-get install of Zeek, it should look Zeek for in these repositories. So I think we are all set. So this is the so see, it is okay. It is contacting that download OpenSUSE.org for all the packages. So that's one of the reasons we added that repository. Otherwise, if you would have just done apt-get install without adding that repository, it would have given you error that it couldn't find Zeek package in any of the pre-installed repository apt-get is looking for. So apt-get install Zeek LTS installs Zeek on the system. So we can check that. So before doing that, Zeek when you install Zeek from pre-binary packages, it automatically gets installed in opt/Zeek folder. This is the default path. If you compile it from source, you can give a prefix like user local or user local Zeek or any other path that you want Zeek to be installed. So since we have installed it from binary packages, it has by default got installed in /opt/Zeek folder. So if you just go in bin, where am I? Okay, I did an ls. Okay, so cd/opt/Zeek bin. You will see the binaries here. So if you just do Zeek help, you will have all the options to run Zeek with. Any case. So the Zeek installation is done. So you guys saw that it was super simple and super easy to install Zeek. After the networking configuration was fixed, it was just a couple of steps and you have Zeek installed, right? So now we will be running Zeek. So there are two modes of running Zeek. One is you can run Zeek in read-only mode. What that means is Zeek will not be actively sniffing from your network, or the Zeek will not be actively sniffing from your interface. So if I give you a PCAP file and I would say that do an offline analysis of that PCAP file and let me know what you find, or let me know what your analysis is or your report. So you would run Zeek in read mode on that PCAP. So that's why there is an option for reading the PCAP read file. So you just provide a PCAP with -r and it will read that PCAP and produce the exact same log files based on what it is seeing in the PCAP. So we would not be going in the PCAP mode, we would be going in the live mode. And how we run Zeek in live mode is using Zeek control. So for that, we need to set all we need to do is we need to set an interface on which Zeek would be sniffing the traffic. So going back one, okay, so where am I? We are in opt/Zeek. This is the default location where Zeek is installed. This is the directory structure. The most important folders you would be looking at is etc and logs. Logs will be the folder where the Zeek logs will be stored when Zeek starts running, and etc is the folder where you configure Zeek to run on your environment. So etc has three files: networks.conf, node, and Zeek control. We will be going ahead and we will be doing a nano of node, and this is where you configure Zeek to run in sniffer mode. You can run Zeek in cluster, and all this logger, manager, proxy, and workers and whatnot is the clusterization of Zeek, like if you have big Zeek cluster. But since we will be running Zeek on one standalone node, we will be just using one standalone mode of Zeek. So host, localhost, it's fine. Interface, here you have to, we don't have any interface, it's 0, right? We have, okay, so we have only two interfaces, an internal loopback and ANS34. This is the one that is NATed, and this is the one that is connected to the internet. So in this interface, you would not see any traffic because it's loopback and it's not reachable, it's private. So this is the interface which we are interested in to sniff, right? So it's ENS34. I think the slides say ENS160. You have to just edit that to whatever interface you are getting an IP address on. We are getting an IP address on ENS34. So I'm just going to use ENS34 here. Okay, so that's the only configuration change you need to do to run Zeek in sniffing mode. I don't have time. Otherwise, I would have gone into much detail on what the other two files look like and how would you define and what is its purpose. So for networks.cf config, if you are running Zeek in production, each organization has their own CIDRs, right? The internal IP address range. So for example, like University of Delaware have 128 dot something dot something dot something. So each organization has its own space. So here is where you will tell Zeek that this is my internal IP address space. And other than that, I mean, IPs that are not in these ranges are external. So this helps Zeek to evaluate some special characteristics of your network, like statistics of whether it is seeing inbound traffic, whether it's seeing outbound traffic, because the way inbound and outbound would be defined is you have to tell Zeek that what are your internal IP addresses, right? So this is the file where you tell Zeek that what are your IP ranges. And Zeek control is the master file where exactly you say different options, like these are the logging options where you want to have where you want to set the log expiration interval, like how many days worth of data you want to keep on your disk. Zeek automatically log rotates your logs, so you don't have to worry about that as well. And then other options which are not very changeable, like you just leave them as it is as default. Site policy scripts, this is where your local.zeek will reside. So if you ever change local.zeek to some path else, you can define it here. Your log directory, your spool log directory, and then your config file, which is /opt/zeek/etc. So these are the three important files in etc directory. And then include lib and share has all its like policy files and library files. You can go into deeper if you would like, but for the time being and for our current tutorial, I do not want to go into detail. One more thing to add is, since we would be sniffing from a NAT box, it might happen that we would get a lot of traffic with bad checksum. And when Zeek hits when Zeek's normal behavior is whenever it sees traffic with bad checksums, it drops the package. So if you're running Zeek and there are no logs getting generated, you would be wondering and scratching your head saying why Zeek is not producing any logs. So you might want to change the H2 settings for that interface. It is just saying that turn off the receiving checksum check, turn off the transmission checksum check. SG is segmentation, TSO is TCP segmentation off, GSO is group segmentation, and GRO is one more thing that I can't remember the acronym full form, so I'm just going to leave it there. So this turns off all the checksumming on our interface. You can check that as well by small k and ENS34. So these are all the settings. So we just turned off the TCP receive checksum, transmit checksum, scatter gather, TCP segmentation of the TSO, which we just turned off TSO as well. Generic receive offload, yeah. So GSO and GRO are these. So GSO and GRO are these. So we just turned off the segmentation and offloading on the NIC so that Zeek can run efficiently. And now we will be just running Zeek. So Zeek, let me export the path. So did I do that already? Where is the path? Yeah. So export path. You can actually run Zeek directly by going into /opt/zeek/bin. But if you don't want to do it again and again, you can just add that to your export bin path. And now you can just run Zeek locally from anywhere, and it will be able to find the binary in /opt/zeek/bin. So whenever you change anything, like whenever you change any type of configuration, whenever you change any kind of script, or whenever you load any kind of script in Zeek, you need to do an install, because this is where it rereads all the policy files, creates the map and structure that where exactly Zeek will look for new files, and it generates just the layout of the cluster. So you need to do Zeek control install whenever you change anything with Zeek. So since we changed node.config, we have to run Zeek control install, otherwise the new changes will not take effect. So after installing, if you have any error in any of the files, you will see it whenever you do Zeek control install. It will tell you that which Zeek file is error, it has error in it, and you have to check the syntax. So since um, it didn't show us any kind of error, and since we would be sniffing in promiscuous mode from our interface, it is going to ask us the permission as root to sniff the traffic. So Zeek has been started. How would we know that Zeek is running? Zeek control has a whole bunch of commands that you can play around with it. So if you do Zeek control status, it will tell you that you have a standalone version of Zeek, which is running with localhost as host name, because we didn't set it in node.conf, and its status is running and its PID is this and the started time. So I know that Zeek is running in the background. So okay, so now Zeek is running. So how to check logs, right? So let's go into the log directories and see if we see anything. So current is the symlink, basically, that points to opt/Zeek/spool/Zeek. This is the path for spool directory that kind of like I showed you briefly in Zeek in networks.config file when I was going into the exit directory. I was showing you that file, right? Not sorry network Zeek control.config. So you set this path, so it's default set, so I don't have to set it, but I can just go in the current and see what's been going on. So it has recorded nothing because it isn't seeing anything yet. So I'm just trying to generate some traffic so that it can generate more logs. So I did ping, right? So that means I'm connecting to internet and I'm pinging Google's server. So it generated a con.log file, but still there are not a whole bunch of interesting files that are getting generated. So let me come to the screen top and let me come out of this current directory. Okay, so now there are some files. So what I did was I just quickly grabbed through the web page, right? So there has to be some traffic related to this query that I just did. So now it has generated some traffic. It has generated ssl.log because it's HTTPS. It has generated http.log. It has generated dns.log because it should have contacted DNS server to resolve the IP address of google.com, and a connection.log file. So this is the network activity that is currently happening on my NATed interface. So this will give you an idea of whatever Zeek sees throughout the network interface. It sniffs that traffic and it creates and produces the log files, and they are flat log files. I can quickly show you some of the log files that it has generated. Okay, so let's take a look at the very basic con log file. Okay, so it looks crazy, but these are the fields. It says timestamp UID, which is connection UID, unique identifier, originator host, which is source IP, source port, responding host, which is destination IP, responding port, which is destination port, protocol service duration, and whatnot, originating byte, response byte, and all the other fields. So you can actually filter down with a unique connection that, for example, if I want to know that what this connection was doing, because my system is contacting an IP address outside, right? And it was an HTTP connection. So let me just grab that unique ID and I can correlate that across all the logs. So what I can do is let's start.log, grep through that connection UID and see if it shows up in other logs. So this connection UID actually shows up in two logs. The first one is the con.log file and the second one is http.log file. So this connection UID is a very important field. So if you are troubleshooting a connection, you can just grab through that unique ID through all the logs and see which all the log files it is present in. So it shows that this connection was an HTTP connection because the protocol detected was HTTP, and it was also seen in http.log file where it was reported. So if I go here and oh, that's the only connection it is there. Yeah, so this is the connection in http.log file. Okay, Victor, time check. So this is the wrap up of, now Zeek is running. So now I have to just stop Zeek, right? Because it will keep running otherwise. So I'll just go again and say Zeek control stop. And do a status check quickly. Stop. Okay, so now Zeek is stopped. And let's see where are the log files. They are no more in current log file, right? So when you stop Zeek, current is a symlink. Current will only hold the logs for the current data. Like if currently Zeek is running, it will all go in the current folder. But if as soon as you stop Zeek, it rotated all the files in current folder, and it actually made a new folder with the timestamp, and it has put all the log files from current to this folder. See, so it has automatically archived all the logs for you that were actually in the current folder. So this was the basic installation and wrap up. So we have a question so is Zeek just sniffing the traffic, or does it detect abnormal behaviors? Zeek is just sniffing the traffic, and it is producing all the log files corresponding to the protocols and traffic it is being seen on the interface. It would not automatically detect abnormal behavior, but if you have correct scripts installed for it to detect it, it is going to absolutely detect it. There's a very important log file that Zeek generates called weird.log file. It hasn't generated it yet because it didn't see anything weird. But anytime Zeek sees any kind of weird activity that is going on your network, it is going to absolutely record it in weird.log file. So there is a whole bunch of session that can be done on that. So cool. Thank you. Alrighty, so time check, you only have 2 minutes, and I think it's pretty much done. So we went through the lab, stopped the Zeek, and summary. If Victor, you want to go ahead and.
Yep. Awesome. All right. Well, thanks so much, Fatima. I know it was a lot to cover in 1 hour, but I'm sure our attendees will appreciate it. All that information you have provided today. Pratap is asking a question: what is our opinion on Snort versus Zeek? Do you want to take that one, Fatima?
Sure. So I get that question a lot, and what I tell them is it's just comparing apples to oranges, right? Zeek is a network security monitoring system. Like it just monitors and it sits and it watches your traffic, and it gives you a holistic view of what is going on in your network traffic. You have to investigate important things and cool things that you want to. So it just gives you log files, right? And if you have there are people who have written lots and lots of scripts that detect really cool things in the network, like scanners, and it detects scanners, it detects SQL injection attack, it detects the HTTP brute forcing attacks and whatnot. So this is what Zeek does. It just gives you a holistic view of the network, whatever at that point in time, that what your network state was. On the other hand, Snort is signature based. Like it doesn't log information regarding to your network that it has seen this much traffic. It just triggers the alerts, and it just puts the alerts in its corresponding alert.log file, right? So it is just a signature based intrusion detection system, where if you have signature, it will trigger, and if you don't have signature, it will not trigger. And so it will not give you the network traffic logs, right? That this is the HTTP traffic going on, this is the DNS traffic is going on. Whereas Zeek gives you that holistic view of your network, that what is transpiring on your network. So it's just like comparing apples to oranges, because Zeek is not really an IDS, but Snort is an IDS, which is based on the signature detection technique.
Awesome. Thank you. All right. So this recording will be available on our YouTube channel. Also, all the slides will be available on our LinkedIn and Twitter. Fatima, if you go to the next slide.
Oh, please. Sure. Sorry. I completely forgot. I have control over the slides.
Right. So if you guys go ahead and scan the QR code, you will be able to get to our LinkedIn, Twitter, and YouTube, where you can find all the recordings for our past sessions. Also, you'll find the recording for this session and the slides. This is part of a Zeek learning series. We're gonna talk about the advanced topics as part of this series. So stay tuned. If you have any questions about Zeek, please contact us. There's an email address on the screen right now. And once again, Fatima, thank you so much for your help today. And thank you for speaking on this topic. Thank you.